Okay, another short video solution for the second part of the Module 1, Lesson 2 review assignment. Same kind of stuff we were talking about on the previous assignment. This time we want to know where the function is. The intervals, meaning x values, on which the function is negative valued. We know that a function is negative valued, meaning the y values are negative, when the function is below the x-axis, so we can just look for those places on the graph. We can see that in this case the function is going to be below the x-axis for all x values to the left of 3. If we move to the left of 3, we can see that the y values of the function are negative, and so we'll include that interval. That interval is only bounded on one end. It's only got an endpoint on the right. And so we only need one inequality. All we have to say is x is less than 3. Or, looks like the other area where this function, the other interval where it's below the x-axis, is this loop right here. And that occurs between the x values of 5 and 7. So then we'd say x is greater than 5 and less than 7. Oops, that's wrong. That's what I meant, less than 7. Did you notice what Moodle did there? I'll just point this out. When you see, if you ever see any pink highlighting in your solution, that's Moodle trying to be a really helpful person and telling you that what you've done is going to be wrong guaranteed because something is incorrect about the format. Well, in this case, we can see that those inequalities don't make any sense. So that would be an indicator that you should not enter that. That looks good. Okay, this function is negative valued. It appears between x values of -2 and +6. That's where the function loops below the x-axis. It's bounded on two ends, so we need two inequalities or a compound inequality. We'd say x is greater than -2 and less than 6. Okay, average rate of change. For average rate of change, I think I'm going to go ahead and add a little line segment on here to make this easier to see. So when we want to know the average rate of change of the function over the interval from x equals -5 to x equals 10. Okay, so what that means, okay, so what that means is I want to know just how much the function is changing between those endpoints. I don't really care what the function does in between. So all I've got to do is I've just got to find what the value of the function is at -5. And if I go back to an x value of -5, it looks like there is the point on the function that has an x value of -5. It has a y value of 2. So if I were to write that as an ordered pair, it would just look like -5, +2. X equals 10, clear over here. When x equals 10, it looks like the function has a y value of -5. And so written as an ordered pair, that's going to look like 10, -5. So if I were to connect those with a line or a line segment, there it would be. All I've got to do to find the average rate of change is just find the slope of that line segment, which I can do with a slope triangle. So to find the slope, I would just start at the left point. We always start left and move to the right. Looks like I would have to move down. Is that right? Yeah. So I'm going to rise by -1, 2, 3, 4, 5, 6, 7. And I'm going to run by, looks like there's +5, and there's 10 more, so 15. And so my answer is the slope of this line segment is just rise over run, which is -7 over 15. The other way I could do that if I wanted to is just by using the slope formula with these ordered pairs, right? I could say that my slope equals y2 minus y1 over x2 minus x1. There's our slope formula. Just change in y is rise, change in x is run. And so that would give me y2 is -5 minus y1 is -2 or +2 over x2, the second point, the x value is 10, and the x value of the first point is -5. So when I simplify, -5 minus 2 is -7. 10 minus -5, when I subtract a negative, that makes it positive, of course, and I get 15 on the bottom. So either way, I get -7/15. Oops. So -7/15. Average rate of change for this function. Well, for this function, it looks like, let's see, at x equals 5, the y value appears to be -1. And at x equals 9, the y value is also -1. So when I connect those with a segment, now the segment is horizontal. Well, if I calculate rise over run, going from the left point to the right point, my rise is 0. The y value didn't change. The run is 1, 2, 3, 4, and 0 divided by 4 is 0. So the average rate of change this time is 0, which makes sense because you might remember from Algebra 1 that the slope of a horizontal line is 0. Okay, so yes, linear regression. Let's go through this one. So I'm going to have to pull up my calculator. This requires a graphing calculator. Okay, so if we look at this here, we're trying to, what situation do we have? An object's speed is recorded at various time intervals. The data recorded in the table, data is recorded in the table below. So speed is v, I guess, for velocity, and t is time in seconds. The input variable here, we're trying to find speed as a function of time. So we're inputting times and getting speeds as the output. So t is like x, that's our input variable. V is like y, that's our output variable. So we know that when we want to do this on a graphing calculator, we go to, first we're going to push the stat button, and this is kind of nice. The buttons that I push will be red. So we push stat, and then we go to the stat screen. We're just going to hit edit, either 1 or enter. Being as 1 is highlighted, we can just hit enter. Takes us here. Okay, so this is where we add the data for the x's and the y's. X's always go in column L1, y's go in column L2. Or more specifically, it doesn't have to be x and y. The input goes in L1, in this case it's t, and the output, in this case is v, that goes in L2. So I'm going to clear these out. Remember, to clear these, I highlight L1 and I don't hit delete, I hit clear, enter, scoot to the right, highlight L2, hit clear, enter, and now everything's gone. I can enter my new data. So the x's are 2, 5, 6, 11, 13, 15, 19. the y values. Let's scoot over to the y column. 5.5, 19.3, 18.3, 35.3, 50.5, 40.1, 62.9. Okay, once I've got all the data in there, this question is only asking me to calculate the best fit line, so I don't even need a graph. If I just want to know what the best fit line or the linear regression line is, all I have to do is do our old stat calc 4. So we're going to push stat, scoot right to the calculate menu, and then hit 4. And then I can just go down to calculate and hit enter. And that is my answer. Notice that the answer is in the form y equals ax plus b, where a is the number 3.199, etc., and b is the number 0.679, etc. So for us, remember that we're using v's instead of y's, and we're using t's instead of x's. So for us, this would actually read v equals at plus b. We want the answer v equals, so we're just going to type the rest of it. So we've got to round all of our coefficients to 2 decimal places. And so I'm going to write a as 3.20 times t instead of x, plus b, which is 0.68. That's our answer. Okay, next. This time we're asked to do something slightly different. This time we want to build the regression model and actually use the regression model to predict the value of v when t is 3. Now we can see in the data table here that when t is 3, the actual velocity that we recorded in our experiment was 4.7. But the answer that we can provide is actually a better prediction than that, because there's error associated with each individual data point. So we're going to go back and repeat the same process we had before. So we'll go into Stat, Edit. L1 is where we put the x values, so I'm just going to change these x values. We go 2, 2 is already there, 3, 6 is already there, 9, 13 is already there, 17, and then 20. On the other side, y values 4.1, 4.7, 12.1, 19.3, 23.9, 27.3, and 45.6. Okay, so once the data is in there, now this time we want to use the model to predict the value of v. So we're going to have to generate the linear regression model. First of all, I'm going to go to my y equals, and I want to just clear everything out that's in there. I'm going to leave the plot on though, and there's a reason for that, which I'll talk about. So I've got my data. I'm going to go Stat Calc 4 again to get to the linear regression wizard. And if I go down to the store regression equation, this time I actually want to graph the linear regression line. So I'm going to insert a y1 there. My shortcut to the y pop-up is alpha F4. So there's my y1. I'll go down and hit calculate, and it gives me the equation. Well, one thing I could do is I could just write down this whole number and that whole number, and I could use the equation v equals 2.032 blah 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 times t minus 0.7549 blah blah blah, and that's going to give me output values for V. Then I could just input a value of 3 into that equation, and that would give me my answer, which I could then round to 2 decimal places. A more convenient and I think a more powerful way to do this is to actually use the graphing calculator. So notice that I've got now, if I go to my y equals screen, I've got my regression equation. The calculator has input that into y1 for me, and I've got plot 1 turned on. The reason plot 1 is turned on is not because I really need to see the scatter plot, but if plot 1 is turned on, then remember that the calculator will take all of the data that's stored in L1 and L2, and if I hit zoom 9, which is zoom stat, the calculator will automatically size the window so that when I look at my graph, all the data points appear there. So that's convenient. That's really the only reason I had the plot turned on, is so I could use that zoom feature. Now I've got the line graphed, and all I need to do, if I want to evaluate my model, my linear regression model at 3, is I'm just going to go to the calculate screen for graphs. Remember, if I've got a graph on the screen, I can hit second calc, and it gives me all of the calculations I can make from a graph on this menu. I want the first option, which is 1. So I'm going to find the y value of the function, in this case when x equals 3, or t equals 3, I should say. The calculator is always going to use x's, but for us, remember that that's actually a value of t. So I hit enter, it puts the cursor on that particular point on the model, on the line, and it tells me that the output, the most likely output that our model predicts is 5.34. That's different than what we actually got, but this is a better prediction of what would happen next time. There it is. Thus ends, I believe that's the last one, yep. Thus ends the video solution.